Good morning, everyone. So, welcome to today's lecture. In the previous videos, we have learned about the what digital system using FPGA. In the previous lecture, also we have discussed what is FPGA, what are the basic components of FPGA, what is the architecture of FPGA, and also the different programming technologies like PAL, that is programmable array logic, PLA, programmable logic array, and PROM arrays, and how to dump the Verilog code in FPGA board, and what are the various vendors related to FPGA, and what are the architectures, and how they are differing from each other as related to the design specification, constraint, and efficiency, and comparison of all this architecture. But not only this, how can we use the FPGA board? The basic thing in using FPGA board is, first of all, we have to learn the coding style where we are writing the code using Vivado tool, and the same code we are dumping into FPGA, and processing is going on for designing of digital system. So before going into depth, we have to learn the basic concepts of Verilog code. So in today's topic, we are going to learn about Introduction to Verilog SDL and Logic Elements. So, what is the full form of Verilog SDL? That is, SDL means Hardware Description Language. How can we describe the hardware components which are used in designing the digital system? So, in Verilog SDL, it refers to hardware description language which is used to model and design digital circuits like processors, ALU, that are arithmetic logical unit, flip-flops, and memory system. Imagine we are writing a logic of a circuit in a language similar to programming, which can then be tested and implemented on actual hardware like FPGAs or ASIC design. This abstraction allows us to simulate complex system, debug functionality early, and target different technologies using the same code. Say, suppose take an example. We are writing a logic for AND gate. So AND gate is a simple circuit. So we can design, and if thereafter any error is there, we can modify and again rewrite the code for building the circuit. But on the other hand, suppose we are going to build a larger system, then we have written a code, we have dumped the code, we have processed the code, and also it has been used to manufacture the bigger system. But after designing the system, after taking so much time, we have got the error in the system level. So after getting the error in such level, what will happen? We have wasted so much time, and again we have to rewrite the code from the scratch level, which again will take so longer time, which is already money waste, manpower waste, and again time waste. So what we can do is, before designing and going to a final stage, and each and every stage we need to test the code, so that at the scratch level, at the step, in one by one step level, we can identify the error, and we can rewrite the code at the initial level only, so that when it takes longer time to build a larger circuit, at the final level we will not commit any error, and the efficiency will also be more. So how can we test it? We can test itself in a FPGA board or ASIC level code. So this is how FPGA is more efficiency to design a logic system. So here we have learned Verilog SDL is a hardware description language for digital system design and used for modeling systems like address, process, memory, etc. And also are technology independent and easy to simulate and debug. So before writing a Verilog code, we need to learn about some basic concepts related to Verilog SDL. So these are the lexical convention. So it are similar like C programming structure. How we are writing in a C programming, Verilog also uses C like lexical rule. So Verilog syntax is inspired by the C programming language. So it is more familiar for software engineers transitioning into the hardware design. It uses tokens like as we are using keywords, identifiers in a C programming. Similarly, in Verilog also we are going to use identifiers, operators, white space to interpret the code. And one more point we need to keep in mind that it is a case sensitive language, meaning reset, RESCT. Suppose we are writing in the capital letter and the same word we are writing in a small letter, each will be entirely different and they will be considered different identifiers. So it are we one point we need to keep in mind is that Verilog is a case sensitive. All keywords such as module and module always and assign are written in lowercase. So we generally follow the keywords to be written in a lowercase rather than the uppercase. So it will have a proper meaning. This case sensitivity is a common source of bugs, especially in naming conventions. So consistency is important. If you are writing in the same word thinking that it will work, but it will not work. So always prepare to write in a lowercase the keywords. It have the logical values and keywords. Unlike typical programming language, Verilog models the uncertainties of real digital circuit using a four-state logic system. So what are those? 0, 1, X and Z. So 0 stands for logic low, that is false. 1 stands for logic high, that is true. And X stands for unknown. Example, uninitialized value means the values which are unknown we will be redefining as X, and Z means high impedance, which are generally used in tri-state buffer. These states help simulate actual hardware behavior accurately. Keywords in Verilog serve as specific syntax rules. For example, always. It always introduces a procedural block. Later we will understand how to write these keywords. Assign means suppose we are assigning any values to variables, then we will use the keyword as assign. And BUF, 0 are the buffer primitives. Case, multi-way decision and control structure, it is essential not to use this as variable names. So what is white space and comments? White space is normally ignored by the Verilog compiler but essential for human readability to maintain the proper format and to maintain the proper design so that humans can read properly. So we are using the space to properly design the code. So it is used for indentation, alignment help, and makes the code structure and easier to follow, and it can be easily understandable, especially in collaborative environment. Comments in Verilog comes in two forms: single line comments and multi-line comments. If we are using this comment like double space, the code will not be, that particular line will not be executed. Even for multi-line comment, if we are using this symbol plus followed by asterisk character, then the particular line will not be executed. So these are used for commenting line. In the next slide, we are going to learn about the various operators which are used for Verilog coding. So there are three different types of operators, namely unary, binary, and ternary operators. So what are the unary operators? Which are require one operand. Example, negation of A. That is, negation is used as a not. And similarly, binary operator, which involves two operands. Example, A and B. So and is a binary operator, or we can write A plus B, plus symbol. So plus is here is for the binary operator, A slash B. And what is ternary operator? These are used for conditional. Example, A question mark B double colon C works like an inline. If else statement we are going to use in the ternary operator. So these operators are normally used in both continuous statement and procedural statement. That is, use always keyword, and continuous statement will use the keyword assign, which are used to build the logic of a circuit. So there are mainly three operators: unary, binary, and ternary. Then The basic thing is number specification. So Verilog will support both size and unsigned number format. The general syntax for size number is, here you can see, size base number. Example 4 tick B 1101. So 4 tick B 1101. How can we define this number? 4 stands for 4-bit binary number, that is 1101. 4 here is for 4-bit and B for binary. Similarly 8 tick D 255. So what is the 8 here? 8-bit, and D means stands for decimal number. Similarly 16 tick H triple F A. So 16 is a 16-bit and H stands for hexadecimal number. So this size what will determine how many bits are allocated to a constant, which is more critical for synthesizing simulation. Unsigned numbers like 25 or thousands are defaulted to machine word length, which varies and may cause mismatches. So always follow to write the size number to avoid any unintentional truncation or overflow. Next, we'll learn about the identifier and string. So, what are the identifiers? Identifiers are the names which are given to various elements in Verilog codes like modules, signals, and variable rules. It must start with a letter or underscore. Can include letters, numbers, underscore, and dollar sign. You see, it cannot use keywords like identity. Example, CLK, data underscore in result underscore temp. Strings in Verilog are written inside double quotes and are typically used for printing messages during simulation using $display or $monitor. You know, right? Print case in the C programming. Similarly, here we have the $display, which will print a particular statement. $display simulation started. Strings must be on one line. What are the data types? There are Verilog has two broad categories of data type. One is net type and the other is variable type. So what is net type? Net type represents physical connection like wires in circuit, because any digital circuit will have a wire to connect from one component to other component and to transfer the signal. So how these are connected and how we can define in the code by using the variable net. So net are used for connections like wires in the circuit. Example WIRE, try. They cannot store value. These are not used for storing the values, rather than they are used as a keyword. And also we have variable types like store values and hold data during simulation. These are the variables which can store the data. Example reg, integer, real. Example, say for example, say example, we are writing wire wire A, comma B. So these are the physical wires. How can you take donate this? Wire AB stands for physical wire, which will create a connection between A signal and B signal. Suppose we have reg, reg sum. So here reg will store the output value inside always block. So a net like wire must be given by continuous assignment or another module, whereas reg is used inside procedural block and retains its value until BSN. Till we have BSN any values to it, it will store the value from till we change. Now we'll go to the next slide. The next topic about the Verilog code is scalars and vectors. What are the scalars and vectors? These are used for defining bit width. Like scalars stand for single bit signal, like clock, either 0 or 1, reset 0 or 1, enable. So these are used for single bit signal. What is a vector? Vector means multiple bit signal or bus like data. Suppose we have data 7 is to 0. This is a vector. Or adder 15 is to 0. We can call it as a vector. So vectors allow for parallel data representation such as in buses, ADUs and memory interface. So suppose we are writing input 3 down to 0 A. So this is a 4-bit input. In case we are writing output 7 down to 0 result. Suppose we want to define it, so for clear understanding that we can write it is a 8-bit output and this is a 4-bit input. Is that clear? Similarly, if you have input 5 down to 0, that means this is a 6-bit input. So vectors are indexed from high bit to low bit and can be manipulated in arithmetic or logical expression like array of this. So what we have learned today? We have learned about what are the basic, what do you mean by Verilog, SGL, and what are the conventions related to Verilog, SGL, what are mean by values and keywords, why we are using white space and comments, what are the various operators. Operators may be unary, binary, or ternary operators. Suppose negation of A means A is a variable and negation in turn stands for not. And ternary, what are the number specifications and what are different identifiers and saying what are different keywords, what are data types. Mainly we have two types, net and variable. Net example wire, try variable example reg, integer or real, which can use to store the data. And net or wire is used for physical connection between various input and output signals. These are the scalars and vectors. So this is all about the basic introduction about Verilog SQL, which can are using in the Verilog SQL. And in the next lecture, we are going to learn how these operators and how various keywords are using one by one in a depth. Thank you for your attention.